Welcome to a mini lecture about colorability. So far in the course, we only have one way to tell the difference between knots or links, and that's the linking number. The linking number, if the linking number of two oriented links is different, then those oriented links aren't equivalent. Now, this is nice, but it's not terribly useful because, for example, it can't tell the difference between knots. Any two oriented knots have linking number 0, so we can't tell the difference between them. This colorability is going to help us. And now the relevant material here is definition 2.1 to example 2.4. So here on the left, it's a bit lengthy, is the definition of colorability modulo n. So let L be a link, does not have to be oriented, and let n be a natural number. This natural number is going to follow us through the whole discussion. It's sort of fixed and in the background. And I'm going to define for you what it means to say that the link L can be colored modulo n. It can be colored modulo n if it admits a diagram, so we always have to start by choosing a diagram, whose arcs can be labeled with integers such that two rules are obeyed. Now, what do I mean when I talk about labeling the arcs with integers? Well, let's go and have a look at this example over on the right. So this link L here that I've drawn, its arcs, well, let me show you an example. Here's an arc. It's what you get by starting at a crossing, going out along one of the understrands, and stopping when you meet another undercrossing. So here's another arc. And in total there are 7 in this diagram. Now, what does it mean to label the arcs with integers? Well, for each arc, let's say for this arc here, I give it an integer number. And here I am labeling all the arcs in an entirely random way. There we go. That's a labeling of the arcs by integers. What's the labeling on this arc? Well, it's 1, it's round there. What's the labeling on this arc? It's 3, it's over here. And this little bit of arc here, that's also labeled 3. Right, let's go back to the definition. So, the link can be colored modulo n if it admits a diagram whose arcs can be labeled with integers in such a way that these two properties hold. First, the coloring equation holds at every crossing. Well, if we had a crossing in our labeled diagram, then it would look a bit like this. The overcrossing would have some label. Let's call it C for the moment, whatever it is. And then the two arcs that go underneath the crossing, those would have labels too. Let's call them A and B. And then the coloring equation simply states that A plus B has to be congruent to 2C modulo n. And the way I remember this is I think that I'm asking the contributions from the two possible directions, the across direction and the up and down direction, to be equal. Well, the contribution from the up and down direction is definitely A plus B, and the contribution from the left to right direction, well, that's 2C because C counts twice, it's on both sides. So that's how I remember the equation. You don't have to remember it that way. So the first condition is that for every crossing, this equation has to be true. And the second condition is that the labels should not all be congruent modulo n. So I can't make all the labels 2. That is because if I did make all the labels 2, then this equation would definitely hold. Have a go at checking that. If I did make all the labels 2, this equation would definitely hold, and everything would be colorable modulo everything. And we would have defined a not terribly useful notion. Now, let's see an example of this. I'm going to show you that this link here can be colored modulo 5. And I came prepared. I worked out the coloring beforehand. And here it is. That's a 1, 0, 4, not quite done. That's 3. And there are 7 labels, which is correct. So, for this mini lecture, forget the question, how on earth did I know to put these numbers there. We're ignoring that for the moment. Let's just learn what it means to say that this really is a colouring. Well, I've labelled the arcs with integers. So what I have to do is have to check the two conditions. So let's check condition number 1, that the colouring equation holds. And let's start by checking that the colouring equation holds here at this crossing. What does the colouring equation say? It says that A plus B should be congruent to 2C. Now what is A here? Well, A is the label of one of the arcs that comes in and passes under the crossing. So 0. What is B? B is the label of the other arc that comes in and passes under the crossing. So the equation is saying 0 plus 3 should be congruent to 2 times C. And what is C? C is the label of the arc that passes over the crossing, which is in this case 4. And that should be true modulo 5. Is 3 congruent to 8 modulo 5? Yes. So what we've established is that the colouring equation holds at the red crossing. Let's check another crossing here. What does the colouring equation say? It says that A plus B should be congruent to 2C. So what's A? A is a label of one of the arcs that comes and passes under the crossing. Let's say it's the label of this one. Well, what is the label on this arc here? I can't see it, but it's there. It's round here, 4. You see the arc goes through this red crossing and meets the green crossing. So the label here is 4. 4 plus B. What's B? Well, that's the label on the other arc that goes under the crossing. That's 1. That should be congruent to 2 times C. What's C? That's the label of the arc that goes over the crossing. What is that label? I can't see it. Yes, I can. It's 0. It's round here. Is it true that 4 plus 1 is congruent to 2 times 0 mod 5? Yeah, 5 is congruent to 0 mod 5. Okay, so let's keep going. I'm going to give all of the crossings a colour, and I think that you should momentarily pause the video and try and write out the colouring equations for all of these different crossings. And then I will write in my answers. Okay, so have a go at writing down all the colouring equations and checking that they're true. And here I go trying the same thing. So for grey, the colouring equation is that 0 plus 1 should be congruent to 2 times 3 mod 5. That's true, right? 1 is congruent to 6 mod 5. For the blue crossing, it should be 0 plus 2 congruent to 2 times 1 mod 5. Good, that's true. For green, it should be 3 plus 1. Do I believe that? Yes. For the light green, it should be 3 plus 1 congruent to 2 times 2 mod 5. Correct. And for pink, it should be 2 plus 0 congruent to 2 times 1 mod 5. That's true as well. So condition 1 holds, and the labels are not all congruent, modulo 5. So too holds. So this is indeed a colouring modulo 5. And that's the end of the mini lecture.